Hello students and welcome to lesson 16 where we are going to learn how to multiply polynomials. In this lesson we're going to apply the product rule for exponents to multiply monomials, mono meaning one. So a monomial is where we just have one term. Okay. Then we're going to review the distributive property, which we've seen in the past, and we're going to use an extended version of the distributive property to multiply polynomials, where poly could mean multiple. So a monomial is one term, a polynomial will have multiple terms. And we are also going to look at special products, which is a couple shortcut rules for the processes we're going to learn before that. Processes, somebody let me know. Um, all right, so application we are building up to. If you have a rectangular lawn with side lengths of x plus 12 and x plus 8, and there is a square patio in the middle with side lengths of x feet, we want to find an expression to represent how many square feet of grass your lawn has. And then we're going to evaluate this function for x equals 10. Okay, so we have a rectangular lawn, and in the middle we will have a square with side lengths of x. So that's going to take away from the grass in the middle, but then we'll plug in x equals 10 to find out how much grass we actually have. All right, we'll come back to that one later. So product rule for exponents. The product rule of exponents states that when multiplying values with equivalent bases, you add the exponents. So for example, 3 times 3 is 3 squared. But really, we just don't write the ones, and so that's why we don't see the product rule of exponents happening here. 3 times 3 is the same thing as 3 to the power 1 times 3 to the power 1. We normally just don't write that 1. So when we multiply 3 to the 1 times 3 to the 1, we get 3 to the 1 plus 1, where we add the two ones together, and that just equals 3 to the power 2, which we know is 3 squared. Okay, if we do x times x, that's x squared, because it's x to the 1 times x to the 1, we add the two ones. If we have other numbers as our exponents, x cubed times x to the 5th, you add the 3 and the 5 to get x to the 8th. But when the bases are not the same, you can't use this rule. You have to leave them separate because they're not like terms, just like what we've seen in the past. So for example, x squared times y cubed is not x to the 5th or y to the 5th because they do not have the same base. X and y are different. We just leave it as x squared times y cubed. We don't do anything with it. Okay? And then if we have numbers in front, so if we have coefficients on the x's, then we actually use the commutative property to rearrange this expression. So if we have 2x to the 4th times 3x squared, the commutative property allows us to move the 3 and the 2 to the front. So we do 2 times 3 in front. And then we put the x terms, x to the 4th and x squared, next to each other. So we add their exponents. So 2 times 3 is 6. And then 4 plus 2 is also 6. So we get 6x to the 6th. But it's important we understand the commutative property is what allows us to multiply those numbers in the front and the variables in the back. So now putting this into practice, now that we know the commutative property is what allows us to do that, we don't have to actually show the commutative property. We can just go straight to multiplying the numbers in front and the variables in back. So on the first one, I'm going to write it out, and on the second one, we're just going to go straight to it. So when we multiply in number 1 here, 16x squared times 3x, this is 16 times x squared times 3 times x. If we get rid of those parentheses, it's multiplication everywhere. And because it's all multiplication, the commutative property allows us to put the 16 and the 3 in front, and the x squared and the x in back. Then 16 times 3 is 48, and x squared times x to the 1 is x to the power 3 because I add the 2 and the 1. But in the next one, I'm not going to write either of these first two steps here. Okay, we can just skip that and go straight to the answer, 48x cubed. So in number 2, when we multiply 5x squared y to the 4 times 2xy cubed, 5 times 2 is 10. X squared times x is x to the power 3 because 2 plus 1. And y to the 4th times y cubed is y to the 7 because 4 plus 3. So we can always just skip straight to that by realizing that we're going to combine the x's, combine the y's, and combine the numbers. And the commutative property, again, is what allows us to do that. Okay, now the distributive property, this is just a review. When we want to distribute something in front of a set of parentheses inside, you'll notice I draw those two lines every time. So in this case, we do a times b plus a times c, where the addition symbol in the middle is what was between the b and the c before. If we apply this for number 3, part A, we multiply this 5 times an x squared, 5 times a negative 3x, and 5, oops, sorry about the keyboard, and 5 times a 4. We get 5x squared minus 15x plus 20 when we work that out. For part B, we're going to multiply the whole thing in front, negative 2x, times each thing inside. Looks a little bit more complicated, but it's the exact same idea. We're just going to apply what we saw on the previous slide now. Negative 2x times 3x squared is negative 6x cubed. We multiply the negative 2 and the 3 to get negative 6, and x times x squared is x cubed because we add the 2 and the 1 as the exponents. Negative 2x times negative 17 is going to make a positive 34x because the two negatives cancel out to give us positive, and we just have that 1x by itself. All right, for part C, we're going to take negative 4x squared and distribute it in to the 1/4 x squared and the negative 0.5x. Negative 4x squared times 1/4 x squared. Well, negative 4 times 1/4, the 4 and the 1/4 cancel, so we just get a negative 1. I don't need to write the 1 though, but it's a negative 1. And then x squared times x squared, add the 2's, is x to the 4th. So it's negative 1 x to the 4th, which is just negative x to the 4th. Negative 4x squared times negative 0.5x is going to make a positive, because two negatives. 4 times 0.5. 0.5 right here is really just 1/2. So 4 times 1/2 ends up being 2, because 4 over 2 reduces to be 2. And then x squared times x gives us x cubed. All right, so negative x to the 4th plus 2x cubed. All right, now we're just going to take that and extend it. All right, so multiplying binomials now. Bi means two. So binomials are terms that have, or expressions that have two terms in them. Multiplying polynomials in general is actually just using the distributive property twice. So instead of doing a times b plus c like we just did, now we're going to have to distribute two terms. Okay, so in this first part over here where we see a plus b times c plus d, this becomes a times c plus d plus b times c plus d, where notice the a and the b were the two pieces of the first term, and the c plus d just stayed where it was. So what this looks like if I draw lines is we're going to take the letter A and multiply it by both things in the second set, and we're going to take the letter B and multiply it by both things in the second set. Okay, so the blue lines are equivalent to these two new blue lines I'm drawing, and the red lines equivalent to the two new red lines I drew. So it's just distributing both things in the first set of parentheses to both things in the second set of parentheses. The next one to the right of it, all that is there's a minus sign in the middle, because if we have a minus b, then I distribute the a just like before to the c and the d, so a times c to d. But when I distribute the negative b, that whole thing, negative b, goes right here, because I'm distributing negative b to c plus d and negative b to c plus d over here. All right, so notice that that sign is the same sign. This negative sign is what was attached to the b in both places. All right, and when we do this, because we have two terms times two terms, we're going to get four terms in our product. And usually we can simplify this, but not always. Okay, so sometimes it'll simplify, sometimes it will not. Okay, when we multiply for number 4 here, x plus 2 times x minus 4, I'm going to multiply x times x and negative 4. That gives me x squared minus 4x. Then I'm going to multiply 2 times x and negative 4, which gives me 2x minus 8. Notice that I had a positive 2x because positive 2 times x, but a negative 8 because positive 2 times negative 4. All right, then I can combine like terms. I have 1x squared term, negative 4x plus 2x is negative 2x, and the negative 8 in the back. All right, and that's all there is to it. So number 5, the only difference between number 4 and number 5 is number 5 is hidden as to what it actually means. X squared minus 5, the whole thing squared, really just means x squared minus 5 times itself, another x squared minus 5. So we're going to do the exact same process. I'm going to take x squared in the front and multiply it by x squared and minus 5. X squared times x squared is x to the fourth. X squared times negative 5 is negative 5x squared. And I'm going to do the same thing now with the negative 5. I'll distribute it to the x squared and to the other minus 5. Negative 5 times x squared is negative 5x squared. And negative 5 times negative 5 creates a positive 25. When I combine like terms in the middle, I have x to the fourth minus 10x squared plus 25, where it was just those two middle negative 5x squareds that went together to give me negative 10x squared. All right, so now you're thinking, well, why only two terms? Why not have more terms? So we can do that just as easily. If I have right here a plus b minus c plus d distributed or multiplied by e minus f plus g, all I do is take the a term and multiply it by the whole other expression. Take the b term and multiply it by the whole other expression. Take the negative c and multiply it by the whole other expression. And take the d. Well, let me wait for those to go away. Take the d and multiply it by the whole other expression. So we're just distributing a to all three things, distributing b to all three things, distributing negative c to all three things, and distributing positive d to all three things. Okay, so you're just taking each term from the first expression and multiplying it by everything in the second expression. Notice that the negative c stayed negative over here. Okay, let me actually put that in green because I have this negative c in green. So this negative c stayed negative because whatever was attached to the c in the first set of parentheses, we keep that attached to the c. So this negative sign stays attached to the c when I distribute it. And in this case, we're multiplying 4 terms times 3 terms. So that is going to give us 12 terms total. And it's possible that some of this will simplify to give us less terms in the additional problem. But I end up with 12 terms when I first distribute because 4 terms times 3 terms equals 12 terms. All right, so now let's go ahead and do it. Number 6, we're going to take x plus 4 and distribute it to x squared minus 3x plus 4. The x goes to all three pieces. So I'm going to get x times x squared is x cubed. X times negative 3x, negative 3x squared. X times 4 is 4x. And now I have to take the 4 and distribute it to all three things. 4 times x squared is just 4x squared. 4 times negative 3x is negative 12x. And 4 times 4 is positive 16. When I look at that, I can see I only have one x cubed term, so I'll put it in the front. I have negative 3x squared and positive 4x squared. Together, that makes positive 1x squared. I have 4x and negative 12x, which gives me negative 8x. And a positive 16 all alone in the back. All right, for number 7, we're going to do the same thing. Now we just have more terms. So I'm going to start off by doing x cubed multiplied by everything in the second set. When I do that, x cubed times 2x squared is 2x to the 6th because 2 times nothing is the 2, technically 2 times 1. And x cubed times x squared, add the exponents, we get x to the 6th. X cubed times negative 4x is negative 4x to the power 4 because 3 plus 1 on the x. X cubed times 3 is going to be just 3x cubed. Okay, now we're going to take the 6x squared and distribute it to all three things. 6x squared times 2x squared, 6 times 2 is 12. And then x squared times x squared is x to the 4th. 6x squared times negative 4x is negative 24x cubed. And 6x squared times 3 is 18x squared. I ran out of space, so I'm going to go down to the next line. I'm now distributing negative x times all three things. Got to be careful whenever you distribute a negative. Make sure you multiply that negative times everything. So negative x times 2x squared is negative 2x squared. Sorry, negative 2x cubed, because x times x squared, x to the power 3. Negative x times negative 4x. A negative times a negative is a positive. So we get positive 4x squared. Negative x times 3 is just negative 3x. All right, one more to distribute. We have to multiply a 5 times all three things. So 5 times 2x squared is positive 10x squared. 5 times negative 4x is negative 20x. And 5 times 3 is positive 15. All right, whole bunch of things we got to combine now. I only see one x to the sixth term, so I have 2x to the sixth. I have negative 4x to the fourth and positive 12x to the fourth. So together that's going to make positive 8x to the fourth. I have 3x cubed, negative 24x cubed, and negative 2x cubed. So 3, negative 24, and negative 2 are going to produce a negative 23x cubed. Okay, then we have 18x squared and 4x squared. Oh, and a 10x squared. So 18, 4, and 10. That is going to give me 32x squared. Okay, we only have two x terms, negative 3x and negative 20x. Together, that's negative 23x. And just the lone 15 in the back. All right, so now, that was all well and good. That's the most important things to know. But there are also a couple quick rules that help us when we're multiplying things we see often. So in your math classes, especially when you go to the next class, college algebra, you're going to see something called conjugates all the time, and you're also going to see squares pretty often. We've already seen one square of a binomial in a previous problem. So up here for number 5, we had x squared minus 5 squared, and you can see we multiplied it out and got this result. There's actually a shortcut, though, to get there a little faster. Okay, so instead of doing a plus b times a plus b, where we multiplied it all out, when you have a plus b squared, there's a formula that cuts to the chase. It's going to be equal to a squared plus 2 times a times b plus b squared, where a squared is whatever the first thing is, squared, b squared is whatever the second thing is, squared, and 2ab, you multiply 2 times a times b. So in the one we did up here, number 5, notice x to the fourth was x squared squared. Okay, so it becomes x to the fourth. 25 was negative 5 squared. And negative 10x squared was negative 5 times x squared times 2. Okay, so we got this result earlier. We just did it the long way. But that one's nice, but the one above it is even better. And we use it all the time. Okay, the product of conjugates yields a difference of squares. So the word conjugate means we change the symbol in between the two letters. So in this case, a plus b and a minus b are conjugates because the only difference is we changed the positive to be a negative. That's called conjugating the expression. Okay? And when we multiply this out, we get a nice convenient result, a squared minus b squared. And you might be thinking to yourself, well, what happened to the middle term, like this 2ab? Well, when you multiply conjugates, that middle term actually just disappears, okay? Because it cancels itself out. So for number 8, I'm going to do it the long way, and then I'll show you the short way. So doing number 8 the long way, we would multiply x times x minus 4 to get x squared minus 4x, okay, distributing that x. Then we would multiply 4 times x minus 4. We'd get positive 4x minus 16. But notice when we simplify, we have x squared, negative 4x and positive 4x cancel each other out here in the middle, and then minus 16 in the back. So instead of doing that, there's nothing wrong with multiplying it out that way, but instead I could have gone straight to, the first thing is x, so I write x squared. The second thing is 4, so I write minus 4 squared, which is 16. So it really only saves me one step, but you'd be surprised how often that comes up. And over time, it ends up saving you quite a bit of steps when you have to do these a lot. All right, number 9. This time, we're not going to multiply it out the long way because we already did that in number 5. We're going to go straight to the formula. So 3x plus 2, the whole thing squared. We're going to do 3x, the whole thing squared, plus 2 times 3x times 2. And the 3x is the first thing, and the 2 is the second thing. So don't be confused why there's multiple 2's in there. One of the 2's is just from the expression. All right, and then plus 2 squared. So if we simplify this, 3x the whole thing squared is 9x squared, because 3x times 3x gives us a 9 there, 3 times 3. 2 times 3x times 2, well, 2 times 3x is 6x, so times 2 is 12x, and 2 squared is 4. Now, you might be thinking, hey, that was like just as many steps as if I multiplied it out the long way. True. However, once you get good at it, you can actually just skip that first step and do that part in your head. So I'm going to show you that for number 10 right now. 4x minus 5, the whole thing squared, is 4x, the whole thing squared. So 4 times 4 is 16. X times x is x squared. Then 2 times 4x times negative 5. 2 times 4x is 8x, times negative 5 is negative 40x. And then in the back, 5 squared, or negative 5 squared technically, is positive 25. All right, so now I'm going to write the step that we would have done before that I said out loud, but I just wanted you to see that once you get good at it, you don't have to actually write out this first step. You end up just knowing what you're doing. So 4x and a 5 there, and then plus negative 5 squared. Sorry, I had a little typo in the middle there. So plus and minus 5. So 4x, the whole thing squared, plus 2 times 4x times negative 5, and then plus negative 5 squared. All right, now we just got to finish off the title slide real quick. So we're going to draw a rectangle to represent this little lawn we have. So whenever it describes a shape, in this case a rectangular lawn, draw a rectangle. Okay, it's never going to be a bad idea to draw the shape they're talking about. So it says the lengths are x plus 12 and x plus 8 here. And then it says we have a square patio in the middle. So, oh, that's a terrible square. Let me make that look more square. There we go. And it says that the lengths are x and x. So we want to find an expression to represent how much grass we have. So if I do a little shading on here real quick, everything is grass except for that square in the middle. Okay, so we want to find out how much grass we have. So what we can do is find the area of the entire shape. Okay, the big shape, the area is going to be x plus 8 times x plus 12, because length times width. And then we can find the area of the little square on the inside, x times x, and then we can subtract these two things. So first, if I find the big area, x plus 8 times x plus 12, we distribute, we get x times x is x squared. X times 12 is 12x. 8 times x is 8x. And 8 times 12 is 96. Okay. The second one, x times x, real simple, is just x squared. And so now if we subtract these two things, that is going to give us the green area. So first, let's go ahead and simplify the blue one. I should have done that already. So that blue expression becomes x squared plus 20x plus 96. But now if I do the subtraction, we're going to have x squared plus 20x plus 96 minus x squared. Okay, where I have the blue expression minus the red expression, because the grass area is the entire rectangle, but minus that little square in the middle. So we're subtracting the two areas there. And what we're going to get when we do that subtraction, notice x squared and negative x squared are going to cancel each other out. So we end up with 20x plus 96 represents the amount of grass we have. Okay, so this is the expression that represents the amount of grass we have. But then it says to evaluate this expression for x equals 10. So now we're just going to go ahead and say if x equals 10, then this expression is now equal to 20 times 10 plus 96. 20 times 10 is 200, plus 96 is 296. And because our measurements were in feet, we're going to say this is 296 square feet of grass. So the amount of grass we have is 296 square feet. Nice, easy application of multiplying polynomials there. Hope you enjoyed lesson 16, and see you next time.